In the annals of engineering, few structures bear a story as tragic, yet as profoundly instructional, as the Quebec Bridge. It was conceived as a monumental triumph, a steel behemoth spanning the mighty St. Lawrence River, connecting two shores, two regions, and an entire nation. But before it could stand as a symbol of progress, it would first become a monument to human hubris. Its construction would etch an indelible lesson into the very foundation of engineering, paid for in blood, not once, but twice. This is the story of ambition, arrogance, and the crucible of catastrophe. For centuries, the St. Lawrence River had been a formidable barrier, hindering economic growth and vital transportation links between Quebec City and points south. Ferries battled treacherous currents and ice flows, a bottleneck stifling progress. The vision of a bridge, a permanent link, had been dreamt of for decades, a testament to Canada's burgeoning industrial might. It promised to unlock immense potential, transforming trade and travel, connecting communities like never before. The challenge was immense, the reward even greater. The selected design was a cantilever bridge, a structure of unprecedented scale for North America. Its main span would stretch an astonishing 1,800 feet, making it the longest in the world by a significant margin. Such a feat demanded the sharpest minds. Theodore Cooper, a venerable American engineer with a distinguished career, was brought on as the consulting engineer. His reputation was impeccable, his judgment considered beyond reproach. He was the guardian of the design, the ultimate authority. His word was law. But even the sharpest minds can harbor fatal flaws. Cooper, in a move that would prove catastrophic, unilaterally reduced the proposed weight of the bridge by nearly £10 million to save costs. He also adjusted critical calculations for the bridge's dead load, its own immense weight. These changes were made with little formal review or recalculation. A minor oversight, he likely thought, an optimization based on experience. But in the colossal scale of the Quebec Bridge, such a minor adjustment planted the seed of an unimaginable disaster. As construction progressed, ominous signs began to appear. Junior engineers, young men fresh from their studies, noticed alarming distortions in some of the compression members, particularly in the lower chord of the south cantilever arm. These vital steel beams, designed to withstand immense squeezing forces, were visibly bowing. They raised their concerns, timidly at first, then with growing urgency. Their calculations suggested these members were dangerously overstressed. The evidence was empirical, visible to the naked eye. The bridge itself was crying out in agony. Yet, these warnings were dismissed. Theodore Cooper, from his distant office in New York, and the senior engineers on site, too steeped in their own authority, refused to acknowledge the gravity of the situation. Their experience, they believed, trumped any newfangled calculations from junior staff. To question Cooper was to question the very foundation of their profession. There was an arrogance, a deeply ingrained belief in their own infallible judgment, that blinded them to the impending doom. They chose pride over precaution, ego over engineering. On August 29, 1907, the bowing of the lower chords became undeniable, terrifyingly apparent. Phoenician Bridge Company's chief engineer, John Deans, finally telegraphed Cooper, detailing the severe deformations. Cooper, now panicked, wired back, "Add no more load to bridge until after I have been over it." But the message came too late. The bridge had already been pushed beyond its limits, screaming under the weight it was never truly designed to bear. The forces of gravity, once obedient, were now on the verge of claiming their devastating due. Just before 5:30 p.m., the unthinkable happened. With over 80 men still working high above the St. Lawrence, a terrifying sequence of sounds erupted, a mighty roar, a wrenching groan, a cascade of cracking steel. In a mere 15 seconds, the colossal south cantilever arm, along with a significant portion of the main span, crumpled. Like a house of cards, the structure disintegrated, plummeting nearly 200 feet into the churning river below. The air filled with screams, then an eerie silence, shattered only by the groaning of twisted metal and the rush of water. The horrific toll was immediate and staggering.
75 workers, most of them indigenous Mohawk ironworkers from the Kanawake First Nation, lost their lives.
They were strong, skilled men, integral to the construction, now swallowed by the river or crushed by steel.
The disaster sent shockwaves across North America, a brutal awakening to the perils of unchecked ambition and flawed judgment.
Families were shattered, communities mourned. The scale of the tragedy was immense, a stark reminder of the human cost of engineering failures.
A royal commission was immediately established to investigate. Their findings were chilling, confirming the whispers of the junior engineers.
The primary cause was not a complex, unforeseeable flaw, but a fundamental miscalculation of the bridge's deadload. Theodore Cooper, despite his vast experience, had underestimated the weight of the structure itself by a significant margin. The members were designed to carry a much lighter load than they actually faced. It was a basic error, compounded by the arrogant dismissal of warnings. The truth was simple, brutal, and utterly avoidable. The collapse of the Quebec Bridge became more than just a historical tragedy, it became a mandatory, somber lesson. Every engineering school across North America incorporated the disaster into their curriculum. It was a stark, visceral case study on the critical importance of meticulous calculation, independent verification, and the ethical responsibility to never let pride override professional skepticism. This bridge, in its failure, forged a new standard for engineering education, a profound shift from unchecked authority to rigorous accountability.
A new era was born from the wreckage.
From the ashes of despair, a powerful symbol emerged. The survivors of the 1907 collapse, profoundly shaken by the human cost of negligence, initiated a unique tradition, the iron ring. This simple, often unadorned band, worn on the little finger of the dominant hand, served as a perpetual, tactile reminder. It was a vow of humility, a commitment to ethical practice, and a constant safeguard against the arrogance that had cost so many lives.
For Canadian engineers, it became an enduring pledge, a personal promise to uphold the highest standards of their demanding profession.
Despite the magnitude of the 1907 tragedy, the need for the Quebec Bridge remained paramount.
After years of deliberation and redesigned plans, a second attempt began. New engineers, chastened by the past, adopted a far more conservative and rigorous approach.
Every calculation was meticulously checked, every component scrutinized. The structure was even heavier and stronger than the original, incorporating lessons learned through such bitter experience. This time, there would be no shortcuts, no dismissive arrogance. The bridge would rise, whatever the cost. By 1916, the two cantilever arms, stretching out from either bank, were nearing completion. The final, and arguably most complex, stage was the installation of the central suspended span. This massive, 5,000-ton steel section had been prefabricated elsewhere and needed to be floated into position, then carefully lifted into place between the two arms. It was an unprecedented engineering feat, requiring precision, coordination, and faultless execution. The world watched, holding its breath, as engineers prepared for this delicate dance of steel and gravity.
On September 11, 1916, the colossal central span was successfully floated into position.
The intricate lifting operation began, a ballet of hydraulic jacks and chains slowly raising the immense structure.
All seemed to be going according to plan.
The air was thick with tension, but also cautious optimism. Then, just as the span had been lifted approximately 38 feet, a deafening crack rent the air. A massive casting, a crucial component connecting the lifting apparatus to the bridge, fractured. The catastrophic flaw was not in the bridge's design this time, but in the lifting mechanism itself. The fracture was instantaneous, irreversible. With a sickening shudder, the entire 5,000-ton central span twisted, buckled, and plunged into the river, barely missing the waiting barges below. 13 workers, caught on the span or near the lifting equipment, were instantly killed. The horrifying specter of disaster had returned, shattering the hard-won confidence of the engineers and the hopes of a nation. It was a different cause, a different set of errors, but the outcome was tragically familiar: more lives lost, more dreams drowned in the St. Lawrence. Despite this second, crushing blow, the resolve to complete the bridge never wavered. The wreckage was cleared, the flawed lifting apparatus redesigned and reinforced. A year later, on September 20, 1917, the central span was successfully lifted and secured into place. The final riveted connections were made. After 2 collapses, 88 lives lost, and nearly 2 decades of effort, the Quebec Bridge finally stood complete. It was a monument not just to engineering prowess, but to an unwavering human determination to overcome monumental adversity. Today, the Quebec Bridge stands majestically over the St. Lawrence, a vital artery of Canadian infrastructure. But its significance extends far beyond its physical presence. It is a silent, towering monument to the profound lessons learned through immense suffering. Its double collapse underscores the relentless power of engineering principles and the devastating consequences when they are ignored or misunderstood. Every bolt, every beam, whispers a reminder of the fragility of even the grandest designs and the supreme importance of diligent practice. The legacy of the Quebec Bridge lives on, not just in textbooks, but on the fingers of Canadian engineers. The iron ring, born from the anguish of the first collapse, is a constant, tangible reminder of the solemn responsibility entrusted to them. It is a vow against complacency, against the arrogance of unquestioned authority. The story of the Quebec Bridge is a testament to the fact that even the most brilliant minds can err, and that true progress is forged not just in steel and concrete, but in humility, ethical practice, and an unyielding commitment to learn from the hardest, most devastating of lessons. The bridge stands, a testament, a warning, and an inspiration.